Welcome to the DIY Honda Garage channel. This presentation focuses on Diagnostic Trouble Codes P0141 and P0161, specifically associated with the Honda Pilot models from 2016 to 2022. DTC P0141 indicates a malfunction in the rear secondary HO2S, or heated oxygen sensor, for Bank 1, Sensor 2, whereas DTC P0161 points toward a malfunction in the front secondary HO2S for Bank 2, Sensor 2. These components are pivotal for monitoring the exhaust gases after combustion in order to ensure optimal engine performance and emissions control. The HO2S sensors are strategically located in the exhaust system, downstream of the catalytic converter, and play a crucial role in adjusting the air-fuel mixture and managing emissions based on real-time data. Detecting faults in these sensors is essential for maintaining vehicle performance and compliance with emissions standards. The errors described by DTC P0141 and P0161 relate to the operation of heated oxygen sensors, or HO2S. The rear secondary HO2S for Bank 1, Sensor 2, which fails with DTC P0141, is designed to monitor the exhaust gases after they pass through the catalytic converter, essentially ensuring that emissions regulations are met. Similarly, P0161 is triggered when the front secondary HO2S for Bank 2, Sensor 2, is identified as malfunctioning. Both sensors are key players in controlling the vehicle's air-fuel mixture and optimizing fuel efficiency. These sensors are mounted along the exhaust pathway, which means any issues with them can significantly affect engine performance and vehicle emissions. Several potential causes can trigger DTC P0141 and P0161. First, a blown fuse can disrupt the power supply to either HO2S. The specific fuse involved is located within the under-hood fuse/relay box and is identified as fuse number A22, rated at 15A. If this fuse is intact, the issue might stem from the relay circuit board, which regulates power to the sensors. Additionally, if the heated element within either sensor fails due to internal resistance issues, it can lead to these DTCs being set. Identifying these causes is critical for restoring proper sensor functionality and ensuring the engine's emission system performs efficiently. When DTC P0141 and P0161 are present, a few symptoms may manifest in the vehicle's operation. The most common early indicator is the illumination of the check engine light on the dashboard. This warning signals that the vehicle's onboard diagnostic system has detected a malfunction within the engine management system, specifically related to the oxygen sensors. Additionally, drivers may notice increased emissions, which can lead to failing emissions testing or higher environmental impact. There could also be a noticeable decline in engine performance, including reduced fuel efficiency and rough idling. Addressing these DTCs is essential, not just for compliance, but also for maintaining overall vehicle performance. The initial step in troubleshooting DTC P0141 and P0161 involves a systematic verification of the vehicle's condition. First, the vehicle should be switched to the on mode. This procedure prepares the vehicle's systems for diagnostic evaluation. Following that, the diagnostic software known as HDS, or Honda Diagnostic System, should be employed to clear any existing DTCs. Once cleared, the engine is to be started and allowed to idle to observe the system's response. The HDS will then be used again to check for any pending or confirmed DTCs. If DTC P0141 and/or P0161 is shown again, this indicates a confirmed malfunction. If not, the issue may be intermittent and require further inspection of wiring and connections related to the oxygen sensors. For the second step in troubleshooting, the first action is to turn the vehicle off and verify the condition of a crucial component. Fuse number A22, located in the underhood fuse relay box. This fuse, rated at 15A, plays an essential role in supplying power to the HO2S sensors. Checking the fuse is paramount. If it is blown, the immediate repair will involve replacing it. If the fuse is intact, it indicates that the IG-LAF02ES subcircuit is likely free of short circuits. In turn, it allows for the focus to shift to other potential causes, such as the relay circuit board that controls these sensors. In the third troubleshooting step, you will need to remove the relay circuit board and perform a thorough inspection. This board is a critical component that regulates power to the heated oxygen sensors. After its removal, use appropriate testing equipment to assess the board's functionality. If the relay circuit board passes the test, it confirms that it's operational and not contributing to the HO2S malfunction. Conversely, if there are any irregularities found during testing, the next course of action is to replace the relay circuit board entirely. This ensures that the oxygen sensors receive the necessary power to function correctly, restoring the vehicle's emission system integrity. In the fourth step, the focus shifts to measuring the internal heater resistance of the secondary HO2S components. Begin by disconnecting the necessary connectors for the front and rear secondary HO2S. Upon disconnection, utilizing a multimeter, measure the resistance between test points on the appropriate connectors. It is crucial that this measurement occurs under specific conditions. When the vehicle is in the off/lock mode and the relay circuit board remains detached, the targeted range for the resistance values should be between 5.4 to 7.3 ohms at room temperature. If the measurements fall within this range, the sensors are functioning correctly, and you will proceed to the next troubleshooting step. Should the values be outside this range, the sensors themselves may need replacement. Step 5 involves checking the continuity of the internal circuits of both the rear and front secondary HO2S, while ensuring the previous conditions from Step 4 are upheld. This requires you to check for the presence of continuity using your multimeter. Connect the test probes to the designated pins in the 4P connectors for each sensor, while ensuring all connectors remain disconnected from the relay circuit board. Successful continuity indicates that the internal circuits are operational, and if confirmed, it suggests the sensors can still function properly. If there is no continuity, this implies a deeper internal fault within the sensors, necessitating their replacement to resolve the issue. In the sixth troubleshooting step, the task involves checking for shorted wires in the SO2HT lines. Start by jumping the SCS, or Serial Communication System, line with the HDS. Allow a wait time of more than 1 minute to ensure accurate results. Following this, disconnect the PCM, or Powertrain Control Module connector, referred to as Connector C, which has 51 pins. Continuity must then be checked between specific points on the PCM connector and the body ground. If continuity is found, this indicates an existing short in the SO2HT lines, and repairs should be conducted to rectify the shorts between the PCM and the secondary HO2S. Otherwise, if no continuity is detected, it suggests that the wire itself is not shorted, and further troubleshooting must be pursued. Moving on to Step 7, the objective is to conduct an open wire check for the SO2HT lines. Maintain the same conditions as earlier, with all connectors still disconnected. Checking continuity involves measuring between certain points on the rear secondary HO2S, front secondary HO2S, and the PCM connectors. If the connections demonstrate continuity, this suggests the SO2HT wiring is intact, and the troubleshooting can proceed to the next step. Conversely, if continuity fails the test, there is an open circuit somewhere along the wire, necessitating immediate repairs. Such open wiring could be a significant reason for the trouble codes and should be addressed. For Step 8, the troubleshooting focuses on ensuring continuity in the IGLAFO2/FI subline. Maintain the vehicle in the off-lock mode while the connectors are disconnected. Employ multimeter testing to ensure that continuity exists between designated points in the relay circuit board and the secondary HO2S connectors. Finding continuity substantiates that the IGLAFO2/FI subline is functioning correctly, allowing safe progression to the next step in the troubleshooting process. However, should there be no continuity, the line itself could be open, thus requiring immediate repairs to restore functionality and eliminate the DTCs. In Step 9, the aim is to check the LAF-RLI line for continuity. Start by disconnecting the PCM connector A, which also has 51 pins. Using the multimeter, continuity testing should be conducted between the relay circuit board and the corresponding pins on the PCM. If the test shows continuity, it suggests the LAF-RLI wiring remains functional and does not need addressing. Alternatively, no continuity in this test indicates an open wire condition, necessitating repairs between the PCM and the relay circuit board before progressing further. This testing step is vital to ensure that all wiring related to the error codes is operational and reliable. Finally, in troubleshooting Step 10, the objective is to check the IGLAFO2 and FI subline for short circuits. Disconnect multiple connectors, including the relay circuit board and all oxygen sensor connections, while taking care with the EVAP canister vent shut valve connector, especially for USA and Canada models. Continuity testing then checks for any shorts in these lines, helping to ensure the integrity of the wiring. If shorts are found, immediate repairs should be completed to address the issues. If the wiring remains intact, further examination of the underhood fuse/relay box should occur, and any faulty components must be replaced, ensuring that the vehicle's emission system returns to proper working order. The last stage of the troubleshooting process involves conducting final repairs and verifying the system's functionality. After completing necessary repairs or replacements, use the Honda Diagnostic System, or HDS, to clear any stored DTCs from the vehicle system. Following DTC clearance, it is essential to conduct an extensive road test of the vehicle to evaluate the oxygen sensor's performance under various driving conditions. Ensure that no DTCs return and that the check engine light remains off throughout the drive cycle. This final verification confirms that the repairs effectively resolve the issues associated with DTC P0141 and P0161, restoring the vehicle to optimal performance and emission compliance. To prevent future occurrences of DTC P0141 and P0161, implementing a routine preventive maintenance schedule is essential. First, make it a habit to periodically inspect the oxygen sensors for any physical damage or excessive wear. Additionally, ensure that all wiring connections are secure and free from corrosion, as bad connections can lead to erroneous readings or faults in the sensor system. Another aspect is maintaining a clean exhaust system. Accumulated deposits can adversely affect sensor performance. Addressing these points proactively not only enhances the longevity of these components, but also contributes to the overall efficiency and effectiveness of the engine's emissions control system. In conclusion, We have thoroughly examined DTC P0141 and P0161, two critical malfunction codes related to oxygen sensor heater circuits in the Honda Pilot from 2016 to 2022. By following a systematic approach in troubleshooting, we could identify key issues such as faulty sensors, relay circuits, or wiring that may cause these DTCs. The importance of regular preventive maintenance cannot be overstated to avoid future malfunctions. Routine checks, clear connections, and ensuring a clean exhaust system are recommended practices that go a long way towards keeping the engine's emissions control functioning optimally. This process not only enhances vehicle performance, but also meets regulatory emission standards, ensuring environmentally responsible driving. Please like and subscribe to the channel. See you next time.